Hello, hello, hello. Welcome back to Science While Gaming with me, Mr. S. Today we are continuing our discussion about chemical reactions and how to express them. I just want to start off by apologizing if you hear any barking or noises in the background. That's probably my new dog, Theo. He's adorable, but this video is not about him. As I said, this video is about chemical equations, well, specifically chemical reactions, but we're getting into chemical equations. So let's kind of pick up where we left off last time. The last time we were talking, we had chemical equations and chemical reactions and what they were. A chemical reaction is a chemical change between two substances, a thing that happens and you produce something new. There were several indicators that we talked about that you can use to identify chemical reaction occurring, but it's not enough to just be like, hey, a chemical reaction is occurring over there. You, as scientists, as people in class, I'm sure your teachers want you to express a chemical equation, a chemical reaction occurring. So you have to have a way of writing it down, because it's not real good science if you don't write it down. You gotta be able to write it. So we express chemical reactions by writing chemical equations. That is the proper way to do it, and so that's the way it is done. Now, a chemical equation, it uses the symbols that are on the periodic table to represent the different kinds of elements that you can have, and the combination of those elements to create compounds. But what do you do with those? What is the point and the purpose? Well, excuse me. The point and the purpose really is to do quite a bit. We want to be able to write down a basic recipe of that chemical reaction, so that way any scientist who looks at it is going to be able to read the recipe and recreate that same reaction. We want to understand it. So just like your favorite recipe at home needs a written down way to express it, you need a way to be able to read it. You go into a cookbook and there's the recipe for the delicious thing you want to make. Insert your favorite food here. Chemical reactions, they work basically the same way. We want to be able to express a thing occurring using these symbols. So a chemical reaction breaks down into several different portions. You have your reactants, those are the things you start with, your products, the thing that you end with, and then you have the symbol in between your reactants and products, and that is known as the yield symbol. It takes the shape of an arrow. That's the whole thing it does. And that's basically it. A chemical equation breaks down into that. Now, what makes a chemical equation is dependent on what is happening in the reaction. So if you have a reaction to create water, you're going to react hydrogen and oxygen together to make water. Now when hydrogen is by itself, the chemical formula is H2. When oxygen is by itself, its chemical formula is O2. And hopefully you are aware that the chemical formula for water is H2O. Also, this cold snap plus solar flare, real bad for this game. Not a great combination. Hopefully nobody dies of cold. So H2 plus O2 gives you H2O. So when you write your chemical equation for this reaction, you're going to express it exactly how I just stated. You're going to separate your reactants on the left side of that arrow, the yield symbol, with a plus. Every time you have a new element, new compound, you separate it with a plus from the other elements. So H2 plus O2 gives you H2O. But there's still a problem here. The problem here is this. Let's just, so that way you can see a little bit easier. gotten a little bit better at writing symbols. So H2 plus, you got your O2. Just because I want to clean it up a little bit. There you go. So H2 and O2. And then you use an arrow, which hopefully you know the shape of an arrow. Honestly, if you don't, that's a little bit problematic. You're going to want to work on that. But an arrow, and then you would have H2O, which I'm not going to draw because obviously I don't have the space for it, but also you really should know. So you'd have H2 and one O attached to it. The problem with chemical equations when you write them is that you need to observe something known as the law of conservation of matter. This law states that you have to have the same amount of stuff that you start with that you end with. Literally, the exact same amount. So you can't create new things into it, you can't take away things from it. It can be in different forms, it can take different shapes, but the stuff that makes it up has to be the same. So in order to do that, we balance chemical equations by using coefficients. So we use numbers we put in the front of chemical symbols and formulas. And this number in front, it balances the equation. This 2 here, I multiply by the 2 that's down here, and that tells me I have 4 H's on this side. On the other side, I'd put another 2 in front of the H2O, and that'll tell me that I have 4 H's on the right of that arrow, and 2 O's, and that matches the 2 O's here. So these chemical equations, they need to be balanced, and you do that with the coefficients. Never touch the subscripts that are here. You don't change those. If you change those, you change the substance you're talking about, and we don't ever want to do that. But it's not just enough to be able to balance it, and really getting good at balancing is just done by practice. It's the only way to do it. It's the only way to get it done. You gotta just knuckle down and get good. The other thing to care about in a chemical equation is what kind of chemical equation it is. See, chemical equations, they can do a lot of things. They can represent a lot of stuff, but they are, in order to make life easier, we categorize them. Just like with everything else in life, everything's got a category it needs to live in. So in order to fit them into the category, you have to know A, what you're talking about, and B, what the deal is. Ooh, got real cold. So in order to know the different categories, you have to be told what they are the first time, and then you have to learn. So there are 5 categories of chemical reactions that exist and that you're going to see in basically the world, and some chemical reactions can fit into multiple categories, and that's okay. They are as follows. You have a synthesis reaction, sometimes also known as a combination reaction, so you have things reacting together. You start with 2 individuals basically, and then you end with one product at the end. So it's a lot like a new couple coming together in this game. People can fall in love, and like these 2 people here, they got married, and so now they're in one bedroom together. They started out in individual bedrooms, and then they got married, and now they share a bedroom. That's kind of what we're going at. We're doing that for a combination reaction. So you're creating a new power couple, a new unit together is another way to think about it. And that's really the best way to explain what a synthesis or combination reaction. It doesn't matter what you start with. It can be elements or compounds, but you start with multiple on the left and you do one on the right. I do not want this thing. The next type of reaction that you're going to want to know is a decomposition reaction. That's basically a couple breaking apart. You start with one unit together and you end with multiple individuals. So in a synthesis reaction, you have multiple reactants, one product. In a decomposition reaction, you have one reactant, multiple products. They are opposites of each other. That's the best way to think about it. And there's no, I don't have a shorthand to memorize these. I don't have a trick to learn them. It's just a matter of, if you really want it, you gotta try. Gotta remember it. And maybe the way that you remember it is by listening to this video more than once, which is fine. Or other videos, search around. I'm sure there's somebody with a much better voice than mine explaining the exact same things. So we're 2 out of 5 so far. Third type is a single replacement reaction. It's what it sounds like. It's one thing replacing another in the chemical reaction. So you start with one, you end with you start with a compound and an element usually, and you end with a new compound and a new element. It's like if you've ever seen, and hopefully most of you have, if you haven't, you definitely should go watch this movie. Go watch Back to the Future. In Back to the Future, in the original, in the first one, Marty McFly's parents are dancing at the Under the Sea dance at the end of the movie. You think it's done, it's over, the big conflict has been fixed, and then some dude just shows up and pushes Marty McFly's dad away from his mom. It's like, hey McFly, get out of here, it's my turn to dance. And then, there's a little drama because he's like, this is a flashback to a thing that started in the beginning, but he's almost, Marty is dying, but because this guy has replaced his dad in the couple that's dancing there. And then Marty's dad gets up and punches him, and it's a whole big cathartic thing, but you really shouldn't punch people to solve your problems. It's not super great. I won't argue that it's effective, but also it's real jerk move. Don't punch people. Be a decent human. It's not that hard. Anyway, so a single replacement reaction. Individual plus group gives you new individual and new group. That's our basic setup here. So you have, it looks almost the same on both sides of the arrow, but the elements will have switched spots. And then our fourth type of reaction is a double replacement reaction. Just like you think it might sound, is two things replacing each other. So I have, in this colony, I think I only have one married couple. But if I had two married couples, and so this is a married couple, and let's say this was a married couple, if all four of them got divorces, so these people got a divorce and these people got a divorce, and then fell in love with the opposite person, then you would have a double replacement reaction because you've now switched partners completely. So it's a total replacement of two things. Now, in a double replacement reaction, that occurs mostly in something known as aqueous solutions. That's just a solution where the solid has been dissolved in water, very specifically in water. Hence aqueous. You will see symbols that indicate state of matter in a chemical equation when you write them and when you see them written. So it is important to know those. It's just S, L, G, and AQ for solid, liquid, gas, and aqueous. Just a thing to keep in the back of your mind so that way you remember it. Best not to forget. The last type of reaction is a combustion reaction. So a combustion reaction, as obvious as it sounds, a combustion reaction involves fire. That's the big deal with combustion reaction. Anytime you produce fire, you have a combustion reaction. In order to have fire, you must have oxygen as a reactant. So somewhere on the left side of that arrow, you will have oxygen, O2 by itself. Gotta be. Without oxygen, you cannot have fire, which is great news. Now, the oxygen can come from different sources, depending. Oh, that's a terrible place for you to hide while being attacked by a rhinoceros. Run away. Sometimes people are real dumb. So, combustion reactions, you are often going to have, you must have oxygen as a reactant in a combustion reaction. If you don't, not going to happen. No combustion reaction. You can use multiple elements to multiple compounds to produce that oxygen separately. It doesn't have to just be there. That is a thing that can happen, but that's besides the point. Most combustion reactions that we know and deal with react with something that's known as a hydrocarbon. Now, hydrocarbon is real simply just a substance that contains hydrogen and carbon. Now, what I'm trying to make right here, once somebody builds it, is a little campfire. Wood is a hydrocarbon. Its chemical structure is made of hydrogen and carbon. That's its main components. We as humans have a lot of hydrogen and carbon in us. That's the deal. Pardon me. So, when you have a combustion reaction that deals with a hydrocarbon, like this campfire right here, this one, this is burning a hydrocarbon. Things that are produced in this reaction are carbon dioxide and water. Every single time you have a combustion reaction with a hydrocarbon, you will have carbon dioxide and water. There is no way around it. It must be produced like that. And that's fine. You just need to remember that that's a thing that occurs. And because that's a thing that occurs, you can often have, like, huge coefficients in your balanced chemical equations. Because some chemical formulas of hydrocarbons are real crazy. Like gasoline that works in the car. Your cars run off combustion reactions. If you didn't know this already, your car's engine, unless you have an electric car, is called an internal combustion engine because it combusts. You have a chemical reaction occurring inside of there. It's blowing things up. That's how it works. If it didn't do that, you would not have a chemical reaction. You wouldn't have a car. Your car wouldn't go. Although now we do have, we do have electric cars, and electric cars do run off things that obviously are not gasoline, which is kind of their whole point. So they don't run off combustion reactions like this, but our traditional cars, they do. So gasoline, its chemical formula basically is a collection of hydrocarbons, but it's basically C8H18, if I remember correctly. And so when you balance that chemical equation of CHH18 plus O2 gives you carbon dioxide and water. And when you balance that out, you end up with like 100 oxygens. So you would have a 100 in front of that oxygen molecule. So you can have a really large coefficients when it comes to balancing, and there's nothing wrong with that. When you are balancing an equation and you see that that's the kind of thing that's happening, don't be afraid of that. It's frustrating because holy crap, I have so many things here, I have to keep track of so much math, but also it's not terrible. It's fine. You're gonna be fine. You just have to make your way through it and be patient. Let yourself actually get it. So those are our 5 types of chemical reactions. Synthesis, also known as combination, decomposition, single replacement, double replacement, and combustion reaction. Every one of those has reactants on the left of the yield symbol, left of the arrow, and products on the right of the yield symbol, on the right side of the arrow. So, knowing that that's what makes up a chemical reaction, those are your basic parts. You can identify a type of reaction that is occurring. You just have to actually, be careful when you do it. And use the things that I've given you to identify them. It's doable, difficult, sure. Especially in the beginning, when you're not good at it, absolutely. But like with everything, you get better with practice. The only way to get good is by practicing. So you must. Wow. Practice, get good, identify. Your science teachers are gonna want you to be able to do that. In your life where this comes into play overall, it's quite honestly, unless you're going into a science field, probably not gonna super come into play. but there are times where it will. Knowing what starts a thing and what ends a thing is going to be pretty important and handy to know and learn. Knowing how to have a reaction that occurs, start with one thing and end with another, it's a skill that's gonna last you through life. So if it'll help you logic out problems more than just in chemistry. And then if you're taking chemistry classes, whether you're in university or primary school or whatever, you're gonna need to know this stuff. 100% you are going to be tested on this at some point by your science teacher, so best learn it now. Get good while you can, and then move forward. Once you're good, once you know, then life is better. Happens quickly, and you can move on with your life and not actually have to worry about it. If you're not planning on going into a science field, the logic, the aspect of thinking logically and getting through these types of equations, because there is a logical pattern to it. You just have to actually sit down and think about it. So if you do that, then that's a great skill to have. If you don't do that, that's going to be a real pain in the butt. You know, not everybody likes this stuff. I get it. You don't have to like it. It is something you just kind of have to deal with. It's going to be a part of your life while you're taking a science class, so you may as well do good at it, or at least do adequate. If you can't do good, be adequate. That's pretty much all I have about these chemical reactions and equations and how to write them and identify them. As always, feel free to drop a question in the comments if you'd like. Clarify something. That's okay. Just ask. I'm more than happy to expand any clarification. These sets of videos really are here for learning purposes, I guess would be the best way to think about that. I don't want to get too on my high horse about it. I just want to help some people. So if it helps some people, great. If it doesn't, then I'm sorry. I wish it would. Beyond that, I'm not going to ask you to do anything else. Just to address some of the comments, as far as I am planning right now, there is not ever going to be any merch. This is a tiny little thing I do in my spare time once a week, and I'm not planning on really doing it any more than this. So, sorry to get your hopes up. I mean, don't get me wrong, if this thing explodes and becomes huge and merch is required, or there's an actual demand for it, and then that might be something I look into. Right now, I'm not really planning on making any money from this. I'm just doing this because I can. I like to help people. I like to teach people things, and it's just me playing a game, rambling on. I don't think there's any real need to monetize or get merch from this, so I'm not planning on it. Everybody's a person. Everybody's human. You deal with it. So, have a good one. Be nice to people. Don't be a jerk. Life's not that hard. Make your life... I mean, it's not that hard to not be a jerk. Make your life easier by not being one. It costs you nothing. It costs nothing to be kind. Really. All you have to do is just be kind. Anyway. Have a good one. Enjoy yourself. Enjoy the rest of your day on whenever you're seeing this. And don't play this video in class. Alright. Ta-ta for now. No, I don't like that. I don't think I'll ever say that again. It just feels weird. Have a good one. Bye-bye.